Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Dear students, this lecture is for grade 7, subject science. And in this lecture, we are going to start a new chapter, that is chapter number 9, which is about the dispersion of light. This is my 24th lecture, and I am your lecturer, Mrs. Saira Jamal. Dear students, as you know that when light passes onto a surface, some of the light is absorbed by the surface, some of the light is reflected, and some of the light refract. This refraction is bending of light from one medium to another medium. When light passes from one medium to another medium, it refracts. This refraction or this bending of light is called refraction. While the light which reflect back in the same direction or in the same medium is called reflection. So when light passes on certain medium, some of the light is absorbed, some of the light is reflected, and some of the light passes through another medium and then it bends away. That bending of light is called refraction. So in this chapter, the first topic is about the refraction. We know that light does not need a material medium to travel. Light travels at different speeds in different mediums. Light travels the fastest through the vacuum. When light passes from one transparent medium to another, it changes its speed and direction. Or you can say that the light bends. This bending of light is called refraction. This bending of light is called refraction. When the light enters from one medium to another medium, it refracts or it bends away. This bending of light is called refraction. But when light falls perpendicular to the surface of the medium, it does not change its direction. When light falls perpendicular to the surface of the medium, this is perpendicular line. When if this light falls perpendicular means when it is making an angle of 90 degree with the surface, then it will not bend, it will just pass straight. So when light falls perpendicular to the surface of the medium, it does not change its direction, it will just straight or pass straight. But when light passes from one medium, one transparent medium, suppose from air, into another transparent medium like glass, when light passes from air into glass, you can see that it is bending. This bending of light when it enters from one medium to another medium is called refraction. The light enters from air into glass and then again from glass into air. When the light enters from air into glass, it bends towards the normal. This straight line is called normal. It is just an imaginary line. It bends towards the normal. But when the light passes from glass to air, then you can see it bends away from the normal. So when light passes from rare medium into denser medium which is more density, which has greater density, you know that air is less denser than glass. So air is called rare medium while glass is called denser medium because the density of glass is greater than air. So when light enters from rare medium into denser medium, it bends towards the normal. And when it enters from a denser medium to rare medium, then the light bends away from the normal. Normal is just an imaginary line. You can consider it as an imaginary line. So this is the imaginary line which we call normal, and you can see that when light will enter from air into glass, it bends towards the normal. So this ray which is in the rare medium is called incident ray, and the ray which is refracted towards the normal or bending toward the normal is called a refracted ray. This angle is called angle of incidence, and the angle of refracted ray with normal is called angle of refraction. Angle of incident ray with normal is called incident ray angle, and the angle of refracted ray with normal is called angle of refraction. This is the boundary between the two medium, air and glass. Important terms: understand the term refraction with the help of the following. First of all, we must know these important terms. The first term is incident ray. What is incident ray? The ray of light that falls on the surface of other medium. This is the ray of light which falls on the surface of other medium. Suppose this is air and this is glass, or if this is water. So the ray is this ray falls on the glass or on the water. So the ray of light that falls on the surface of the other medium I told you may be glass or maybe water. Refracted ray, the ray of light that changes its direction in the other medium. Incident ray, when falls on other medium, I told you the medium may be water or glass. You can see that it is bending. This incident ray bend towards the normal, or it is moving towards the normal line, which is an imaginary line. So this ray is now called refracted ray, the ray of light that changes its direction in other medium is called refracted ray. Normal, I told you these dotted lines is normal, an imaginary line drawn perpendicular on the surface. I told you perpendicular mean this line is making an angle of 90 degree with the surface. So an imaginary line drawn perpendicularly on the surface of the medium, the point where incident ray falls on the surface. So we will make at that point, exactly at this point where the incident ray fall on the surface, exactly at that point we will draw an imaginary line which is called normal. Then angle of incidence, this is angle of incidence, the angle between the normal and incident ray, or the angle which the incident ray make with normal is called incident ray and incident angle, and it is represented by a small I, also called angle of incidence. Angle of refraction, the angle between the refracted ray, or the angle which is formed by the refracted ray with normal, is called angle of refraction, yeah, or refraction, angle of refraction. So you can see it is represented with small r. The angle between the normal and the refracted ray is called angle of refraction, and it is denoted by a small r. These are some important information so which help us to understand the refraction or bending of light. We have an activity to understand the effect of refraction. For this you need a plate or a bowl, water and coin. Procedure is take a short opaque plate or a bowl and place a coin at its bottom. You can see we place a coin at the bottom of this cup or this bowl. Then position yourself in such a way that the coin is just not visible to you. Keep this ball on a table and then move away from the bowl or from this cup in such a way. Just go away from the bowl or from the table on which you keep the cup. Move away until just stand on that position where you could not see the coin in the bowl. Then tell your friend or your partner to put water in this bowl or in this plate, and don't change your position. Just stay on that position where you went before, and see when your partner or your friend put water in the bowl, what will you see? The coin is now visible to you. How is the coin visible to you after putting water in it? Before water means If there was no water in the bowl, only you kept coin inside the bowl, and you just went away a little bit farther from the bowl, and you are not able to see the coin. But after putting water by your friend or your partner in the bowl, or from the same position which you are standing, you will be able to see the coin. So what is the phenomena, or how you are now able to see the coin? So when the coin is not visible to you, the reason was that the rays of light traveling from the coin in straight line are not able to enter your eyes. The rays are just passing perpendicular to the coin, and then they are not bended or not reflected, so you are not able to see the coin. But after putting water in the bowl, the change of medium occurs. The medium before was air, and now when you put water in it, now the medium is water. So we change the medium. The change of medium occurs. Now no light has to travel from water into air. Now the rays are not passing from water into air. The rays are passing from air into water. So when the rays are moving from air into water, they will bend away. Due to the bending of light, that bending light will enter in our eye, and then we will be able to see the coin in the bowl. So how could we see the coin in the bowl? What is the phenomena? The phenomena which help in the bending of light, and then those bended light will enter in our eyes, is refraction. So we could be able to see the coin by which phenomena? By the phenomena of refraction. Refraction in different mediums, refraction in water, in glass, in any metal, or in air. So refraction takes place in different mediums. You can see when light passes from air to water or glass, it bends towards the normal, and the angle of incidence is greater than the angle of refraction. This sign is for angle of incidence, greater than angle of refraction. When light passes from water or glass to air, it bends away from the normal, and the angle of refraction is greater than the angle of incidence. There are two different processes. When light passes from denser medium to a rare medium, the medium which has more density, or it is denser or heavier than the other medium. So denser medium definitely is water or glass. So when light passes from denser medium, means from water or from glass, into rare medium is air. So you can see the refracted ray, it is bending away from the normal. You can see this angle is too like a big angle is over here. Angle of incidence is small, and angle of refraction is greater. In this case, angle of refraction is greater than angle of incidence. You can see angle of refraction R is greater than angle of incidence. This takes place when, in which case, when the you can see N1 is the density of the medium. N1 means the density of N1 is greater than N2, or this is denser medium and this is rare medium, the lighter medium. In this case, what happened in denser medium? When the light enter from denser medium, from water or glass, into rare medium, means in air, what happened? The light bends away from the normal, and you can see angle of refraction is greater than angle of incidence. Second case is when light enters from rare into denser medium, means from air into water or glass. When the light enters from rare into denser medium, the ray bends towards the normal. It is going closer to the normal. That's why the angle of refraction you can see is smaller than the angle of incidence. So in this case, angle of refraction is smaller than angle of incidence. So medium actually affect the bending of light, or medium affect the process of refraction. Either the light is entering from denser to rare medium, or from rare to denser medium. Extend your thinking. A light wave is bent more as it travels from air to glass. than in traveling from air to water. Is the speed of light greater in water or glass? So in next slide, inshallah, we will discuss a phenomena or a term which is called refractive index. The bending of light or the refraction actually depends upon the refractive index. So greater the refractive index, lesser will be the speed of light, or lesser will be the bending of light. And smaller refractive index means greater will be the speed of bending. So light travel at approximately 300,000 kilometers per second in a vacuum. It means that the speed of light in vacuum is fastest, which has a refractive index of 1. But it slows down to 225,000 kilometers. From 3,000, it decreases to 225,000 kilometers per second in water, and then and the refractive index of water is 1.3, and then further decrease to 200,000 kilometer per second in glass. So it means that the refractive index of glass is greater, it is 1.5, and I told you greater the refractive index, lesser will be the speed of light in that medium. So the speed of light in vacuum is fastest or highest, then it is in water, and the least is in glass, because the refractive index of glass is highest 1.5. So lesser will be the speed. You can see 200,000 kilometers per second in glass. So and also you can see here that when light moves from the rare medium into the denser medium, it bends towards the normal. Here angle of reflection is 34.5 degree. Bending is less. This is less bending because the speed is slow, and here the bending is more bending because speed in water is greater. So 40.6 degree is the angle of reflection, and the bending is more in this case because the speed of light in water is greater than that of the glass. Laws of refraction, there are two laws of refraction. The first one is the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. All lie in the same plane means that we are drawing all on the same paper. We will take just a white paper and we can draw incident ray, refracted ray, and normal all on the same paper. And second is the ratio of the speed of light in vacuum to its speed in another medium is always constant. Speed of light in vacuum, or the ratio mean divided by speed of light in another medium is always constant. And this second law is also called Snell's law. To understand this activity or this refraction, we need we'll do another activity. For this activity, we need drawing board, drawing pens or common pens, pencil, scale, a white sheet, a glass slab, and this protector or D. Then procedure is that fix a white sheet of paper on a drawing board. Take a white paper, fix it on a drawing board. I took here a purple paper, so you can take a color paper or white paper and fix it on the drawing board. Then put this glass slab on the paper and draw margin with pencil, like a rectangle of this glass slab with pencil. You can see here this is the rectangle which we draw from this slab. So put a glass slab in the center of the paper, draw the boundary of the slab, and then give them a name A, B, C, D, or P, Q, R, S, whatever you want. So A, B, C, D are the name. Fix two pins P and Q on the paper. These are the two pins. You can see the two common pins or the two pins on this paper. These are the two pins which after removing I just mark it with pencil. Fix two pins on at one side of the slab on the paper in such a way that they make an angle with the slab. You can see they are making an angle with these pins are making an angle with the slab. Look for the image of the pin from the other side. Now go at the other side like as you put the pin here, so come at this side, and see the image of these two pins here in this glass slab, and then in that line put two more pins, one pin here and one pin here. When you will see it from this side, from this glass slab, by closing one of your eye, then put the two common pins in the way that all the four common pins, they look same in a straight line. So look for the image of the pin from the other side through the slab. Fix two more pin R and S in line with the image of P and Q. These are the two more pins in line of these two pins. Remove the slab, then remove the slab and just join these slab and also the common pin, and then make circle or make squares of the common pins where they were first fixed. And what you will do next, you have to join these lines with the by using the scale. Also draw the normal. As I told you, you have to draw the normal at that point where the incident ray fall on the surface. Make normal here, and also make normal here for this ray. So this is actually the required angle of incident. This is this is incident ray, refracted ray, and then emergent ray. So join P and Q as the incident ray to AB at point O, AB or whatever we want. These are the incident ray, and these are the refracted ray, which is or the bending ray. Join all these point P and Q as an incident ray to AB at point O. Join R and S as a refracted ray to CD at point L. So this is point L, and these are the CD, point L. These C. Actually, the alphabets are different, but you can say this is A, B, and C, D. A, B, C, D is the slab, and these two are P, Q. P, Q are the two pins which you fix first, and then R, S. These are the other two pins, R, S. P, Q, R, S. So then the points, this point is, they consider this point as O and this point as L. So point O and point L. Join O and L, and then draw normal at point O. You have to draw normal at point O. We can call it the NOM, or we can also call the normal at the other side as P Q, P Q, and this is L. So P Q L. Fix P and Q pins at different position and place R and S pins on the other side of the slab accordingly. You can see that the incident ray, the refracted ray, and the normal at the point of incident all lie on the same plane. Incident ray, refracted ray, and normal all lie on the same paper. So you can say all lie on the same plane. This was all about the process of reflection. Then another topic is refractive index. I told you that the speed of light varies in different medium. Some medium cause light to bend more than other when it passes through them. So the degree to which medium can bend light is given by its refractive index. Refractive index, I told you, it depends upon the refractive index. Speed of light, velocity of light depend upon the refractive index of the medium. And how can we define refractive index? We can define refractive index as refractive index is the ratio of the speed of light in vacuum to its speed in the medium. Or we can write the formula: refractive index is equal to speed of light in vacuum divided by speed of light in the medium. This is called ratio. Divided by means ratio. Speed of light in vacuum, ratio of speed of light in vacuum means ratio in speed of light in vacuum divided by speed of light in any medium. So refractive index, in simple word, how can you say what is refractive index? This is a measure of how much light slows down when it goes into a new medium, like when it goes from air to glass or from air to water, how much its speed slows down or how much the speed of light decreases. This is called refractive index. So refractive index is the measure of how much light slows down when it goes into a new medium, and we can represent it by small n and n in vacuum is equal to 1, means refractive index of vacuum is 1. N medium equal to speed of light in vacuum divided by speed of light in any medium, that may be glass or water. Here we have some refractive index value. As I told you, refractive index of vacuum is 1. Helium is 1. Tetra 036, water is 1.30, sugar solution is 1.38, glass is 1.5, diamond is 2.4. And as I told you, greater the refractive index, slower will be the speed of light in that medium. So the speed of light is the fastest in which medium? In vacuum, because its refractive index value is the least or the smallest. The highest value is for the diamonds. The speed of light in diamond is the least, because I told you greater the refractive index, lesser will be the speed of light in that medium. So if we compare glass and water, speed of light in glass is lesser than the speed of light in water, because refractive index of glass is greater than water. Then real and apparent depth. Sometimes reflection of light give us a false impression of the depth and position of object in water or glass. For example, we have noticed that clear swimming pool looks shallower, and we think that it is shallow and we can swim in it. But actually, when we go down, the depth is too much. So it means that that was not real depth. We from outside, when we are standing outside, the depth looks apparent, and apparent depth is lesser than the real depth. So why we can see the image, or we can see, suppose if a chest is in water, so the chest is looks shallower in water, although it is present in deep under sea. The reason is, or the phenomena is, again refraction. Due to refraction, the objects appear closest to the surface of the water, but actually they are in the depth of sea. So sometimes reflection of light give us a false impression of the depth and position of objects in water or glass. For example, we have noticed that clear swimming pool look shallower than their actual depth. It is because of reflection of light. Light travel faster in air than in water. So when light passes from a denser medium, like from water to denser medium, from water to rare medium to air, when light passes from denser medium, from water to rare medium to air, what happened? As I told you, that it bends away from the normal. So when the light bends away from the normal, when this reflected light enters our eye, so the bottom of the pool and objects lying in the bottom appear close to us than they really are. Although really they are far apart, very far, but they look closest to us due to the refraction of light. So dear students, I hope you understand these topics which were about the refraction of light, and inshallah the remaining topics we will discuss in our next lecture. Till then, take care. Allah.